This question is from Strength of Materials for 2 marks. Consider a prismatic straight beam of length L is equal to pi meters pinned at the two ends as shown in the figure. The beam has a square cross section of side P is equal to 6 mm. The Young's modulus E is 200 gigapascals and the coefficient of thermal expansion alpha is equal to 3 into 10 power minus 6 per Kelvin. The minimum temperature rise required to cause Euler buckling of the beam is dash Kelvin. For this numerical answer type question, the accepted answer range is 1 to 1. Let's proceed to the solution. We are given with the length of the beam as L is equal to pi meters and Young's modulus as E is equal to 200 gigapascals. We are given with the side of the square cross section as P is equal to 6 mm. So from that we get the area of square cross section as 36 mm square. Now let us calculate the moment of inertia for a square cross section, which is P power 4 by 12. And substituting P is equal to 6 mm and simplifying will give us I is equal to 108 mm power 4. We are also given with coefficient of thermal expansion as alpha is equal to 3 into 10 power minus 6 per Kelvin. Now according to Euler's buckling theory, we get the critical buckling load as P is equal to pi square EI by L effective square. Since the beam is pinned at both ends, the L effective is the effective length will be equal to the length of the beam. So from the concept of thermal stresses, we can write the thermal stress as E alpha delta T, but we know that stress is equal to load per area. So from that we can write the thermal load as P is equal to E A alpha delta T. Now, since the buckling load and thermal load should be equal, we can write E A alpha delta T is equal to pi square EI by L square. So from this equation we can cancel out E on both sides. We have A is equal to 36 into 3 into 10 power minus 6 is the coefficient of thermal expansion alpha. Delta T is the unknown, which is equal to pi square into I, which is 108, divided by L. Since L is given as pi meter, converting that into mm will give us pi into 10 power 3 mm and square of that. So simplifying this will give us the temperature change, the minimum temperature change required to cause Euler buckling of the beam to be 1 Kelvin.